Hi Professor, this is Naincy Gupta, and in this video I will be talking about 3CNF satisfiability or 3CNF set. Now what is CNF? CNF is an acronym for conjunctive normal form. Now to first understand 3CNF set or CNF set in general, we have to first understand what is literal and what is clause. So in a Boolean formula, a literal is an occurrence of a variable or its negation. The next concept is clause. Clause is a combination of literals. In our case, a combination of literals using or. So there are a bunch of literals connected with each other using or. That is what is known as clause. Now in a CNF, it is an end of multiple clauses, and each clause, as I said, is or of one or more literals. So this is what CNF is. So let us take an example for a particular formula such as x1 or x2 and not x1 or x2 and x2 or not x4. So here x1 or x2 is a clause and x1 and s2 are two literals. So there are each clause is having two literals. Clauses are connected to each other by an and. Here we can see that is either a literal or its negation. For example, we have x1 and we have not x2, not x1. So in the formula, each clause has two literals. So this formula is called 2CNF. Now we will look at 3CNF. Here each clause is having three literals, such as we can see in this example. Here it is x1 or not x1 or not x2 and x3 or x2 or x4 not and not x1 or not x2 or not x4. So here each clause is having three literals. So this formula is CNF. Now in 3CNF set, which is the problem that we have to discuss. So 3CNF set is a problem in which we have given a Boolean formula phi, which is of this particular form that is it has three literals in each clause, which we have to figure out if it is satisfiable or not. So what is satisfiability? Satisfiability is to try to find out an assignment to different variables such that the formula yields 1. So we can see that in this particular case, all these clauses, each clause has to evaluate to 1 for phi to evaluate as 1. Uh, and we can see that each of them has been connected by an and. So let us see the above formula once again. We can see each of the clause is connected by AND operation. So it is just that if we just take one clause out of it, and we see that even if one of the value is 1, we can also say that if at least one of the literal value is equal to 1, then the whole clause will yield a value of 1. So let us assign some values to x1, x2, x3 and x4, as x1 and x2 will be 1 and x3 and x4 will be equal to 0. And if we assign these value in this formula, we could easily get that each clause is yielding us one value every time, and when we AND them all together, we get phi as 1. So each clause gives us 1 and the resultant that we get is 1. So for this particular assignment, we can find that phi evaluates to be 1. So it is satisfiable. So the goal of 3CNF set is to find this assignment such that the Boolean formula phi is satisfiable. So why do we study CNF set problem? Because it is very important for proving NP completeness. So we should know that 2 CNF is solvable in polynomial time and 3 CNF set is a NP complete problem. So first we will see that 3 CNF set problem belongs to NP problem. This verification can be done in polynomial time. Now we already know that satisfiability problem is an NP complete problem. So if we are able to reduce satisfiability problem to 3 CNF set problem, then we can also state that 3 CNF set is an NP hard problem. And since it is both NP and NP hard, hence it is an NP complete problem. So we can reduce set to 3 CNF set in the following situation. So we will be considering a Boolean formula for this named as f is equal to x plus yz, where x, y, z are the three literals. We can convert this into 3 CNF form in the polynomial time. So we will be applying the OR operation here to get through to the next step, where we will have the equation as x plus y and x plus z. Now we will add z dash because it is 0, because we are doing an AND operation of variable and its complement. This value will become 0. Same way we will add y and y dash, and we will expand it further in the same way. So we can reduce the satisfiability problem in 3 CNF form. In the polynomial time, this is 3 CNF form because we have 3 literals in one clause. So we can say that 3 CNF set problem is a NP hard problem, and previously we saw that it is a NP problem as well. Hence 3 CNF set is a NP complete problem.